This building here was a building that really changed my life dramatically. That's me there many years ago in one of the world's first computer graphics laboratories. This guy in the front here, when he gets a haircut, he's going to become CTO of Autodesk. And right across the hall is another guy who's very tall, who's going to become the CEO of Autodesk. Now, we were all students. We were students of this professor, Professor Don Greenberg. And what was Professor Greenberg a professor of? He was a professor of architecture. That's right, this building that changed my life was really in service of buildings. There's a colorful history about this building too that involves police raids because of a prototype laser printer. There was FBI investigations that went on here because the very first internet virus that took down every Unix machine on the internet and most banks started in that same building. And I could go on and on with a lot of colorful history. But for us, talking about buildings, this was very interesting. This is a building going through an earthquake simulation, finite element analysis on a machine that was an Evans and Sutherland vector display. This is before pixels were really popular. We didn't have enough memory to show a high resolution picture with pixels, so we used vector displays. And this here is Professor Tony Angrafia. He is doing FEA to really avoid what would have been an amazingly horrendous disaster based on a government secret that you can't really talk about, but you can imagine. So you can thank Tony in this same building for his work. He later went on to invent oil fracking and spent the rest of his life and is still working to get that outlawed. So I am not an architect. Yeah. And I'm in Texas, right? So I'm not an architect, I'm a technologist, but I've been serving the AEC industry for over 35 years. I've written code that has ended up in dozens and dozens of the most popular CAD software programs. So, for the last 20 years, it's been, out of these 35 years, it's been increasingly obvious to me that I've been wrong. I've slowly realized this. But before we get to that, okay, I want to review my understanding of the necessities that you as AEC professionals are facing. You know, even before we think about this explosion of AI, I've got these notions about how we need to reinvent the industry, how we're going to move forward. I'm going to show you some examples of these notions in practice with what we have now. I'm at a startup company. We've built a product. I can show you some demonstrations of these notions and what they can do now. And then I'm going to close on some ideas of where we go next. All right, so as far as this necessity, we live in this world where we've got to build 1,000 buildings per day just to keep up with demand. You know, it's an incredibly wasteful industry. There's been a lot of analysis that said about 1 out of every $3 spent in construction turns into waste, and that's often due to poor planning. So I think in your businesses, you've all seen that project complexity has really been growing, your competition has been growing, your risk has been growing, especially with things like AI, risk has gone up. And for some of you, you're seeing your profit be compressed by all of this. You've got these tools that you have that are really good at helping you with coordinated documentation, but you have a much bigger problem than that, which is coordinating delivery. So you have all these new demands on you, but you have the same old challenges. You've had these challenges for decades now. And I like to summarize these challenges as falling into 3 categories. It's really about people, it's about data, and your tools. And if we were to summarize the summary, I use the word fragmentation. You see, a building project has all of these people involved. You've got fragmentation of people working at hundreds of different companies that it takes to make a building like this, and they're performing in these dozens of disciplines. And that fragmentation comes when you try and collaborate across all of these different disciplines, across all these boundaries between companies. And you know the mess, you live this every day. But another form of fragmentation is really about the data and how we represent things with this data. So take a simple door, for example. Consider how many places you represent that door. You've got a 3D BIM model of the door, construction documents for the door, warranties for the door, cost estimates for the door, delivery schedules for the door. You've got a photograph of the door's serial number once it's installed. That door is in a lot of data in a lot of places. The third type of fragmentation is really about the tools that you use, okay? And how you manipulate that data with those tools. And also how you store that data, the repositories across many organizations where that data is held. So coordinating a change across multiple people, working at multiple companies, using multiple tools with multiple repositories, it turns into the mess that we all know very well. And this is where some of you get a lot of billable hours out of this, and for some of you this is a big cost, which is lowering your productivity. And how much time do you guys spend looking for something? If your business has been around for decades, you probably have hundreds, thousands, millions of examples of different aspects that happen frequently, but you simply can't find the data. Now, the interesting thing is that there's another industry that has a lot of the same issues, right? The manufacturing industry builds things, just like we do. In fact, they might build 1 million chairs over decades with a set of suppliers, right? They have much less of a fragmentation problem. And that's because they organize around standard data schemas. They use standardized tooling, and they do their communication through standardized paths with that tooling. And this is where the idea for BIM came from, building information modeling. BIM promised to centralize all the project data into one central coordinated store, one schema for the data, one way of describing it. It also promised to coordinate all the tooling. You know, Revit was a huge leap forward when it started. It gave us that coordinated construction documentation. And much later it started to add in other modules where we had structural analysis, we had the architecture, we had the MEP, we had all these different tools that came into that unified model. And so yes, there was some productivity gain, and it's been very successful. But it only reduced 2 of our 3 types of fragmentation. And then later, with the popularity of the cloud, we had this promise of solving that 3rd type of fragmentation, which is really about the people. So I spent 20 years of my career trying to realize this very seductive picture. It's seductive to the AEC professionals because it promises to solve the 3 types of fragmentation, okay? Our people coordinated in the cloud, our data in a unified centralized data schema, and our tooling applied to that data. It was also very, very seductive to my former employer because it put them at the center of all economic activity. And this is where I went wrong. Because while I tried to build this picture for 20 years, unlike in the manufacturing industry, in AEC, we build one San Francisco airport. We do it with one ephemeral team, and we do it over a short engagement. And as hard as I tried to make this picture work, the result was always this: more fragmentation. You might use Miro for inspiration at one client. You've got Rhino at another company doing some neat design. You've got Revit being used for documentation at another company. So you've got this BIM model that the architect has. There's a BIM model that the contractor has. You've got another model at the structural engineer and the MEP. There's all these models, all these storage, and the fragmentation goes on. So unlike in manufacturing, it's kind of unrealistic for our industry to expect that we can centralize all the data of all these players. It's unrealistic to have a single schema, a way of describing data, and it's unrealistic that we're all going to use the same tool set. And if I hear you right, this industry is in a lot of pain. There's a lot of change happening now with AI. There's some fear. And given recent trends, I think we're at an inflection point between these challenges that we're facing, but there's also some interesting new opportunities, which is why you're here. So I might have been wrong about that seductive picture that manufacturing gave us. And I don't believe anymore that some standard file format like IFC is going to save us. I don't think a single vendor or a single tool or a single model is going to save us. I don't think that's the answer. If anything, what decades have taught me about this industry is this new notion, and that is that fragmentation exists, and that we should embrace it rather than fight it. Think of the internet. The internet is messy. You've got lots of data on the internet. It's owned by lots of companies. It's acted upon by lots of services. Those services are run by different organizations. And yet all that chaos of the internet works. Google does not need to own all of the internet data in order to organize it. Zapier does not need to host all of the cloud services in order to connect them. Somebody like Slack does not need to employ all of the people of the world in order to coordinate them. So think about in the web how I can have a website from company A, I can have a weather service from company B, and I can have a mapping service for company C, all integrated and linked into one experience where we have distributed data, multiple schemas, not centralized but linked. That's a new way of thinking. Actually, it isn't a new way of thinking for AEC. There have been attempts to do this before, but it's very hard to implement that vision in our market. You know, things like IFC have tried to standardize that, but it's been brittle with that file format that's out of date the day it's published. We also have seen architects who've used APIs and things like Grasshopper, Dynamo, people who are kind of lightweight software engineers, lightweight coders that have been able to write all this code to try and connect systems together. It works. It does reduce the fragmentation and the friction, but it's brittle, and it's not enough. So for 20 years, linking these fragmented sources of data has been slow, expensive, and as I mentioned, brittle. So you might have one tool that describes somebody's name, like John Doe, where you got another tool that describes it as a first name and a last name, John and Doe. And so one tool might use feet, another tool might be using meters. This translation is a huge point of friction when you're trying to solve this problem. Now for decades, I think computing has been what I call digital. It's been very precise, it's very accurate, and it's very, very rigid. You know, I use this word digital to talk about this translation problem where you have, you know, these common schemas, centralized databases, standardized file formats like IFC. You know, all of these things are very precise, very digital, and very brittle because of that translation problem. And this really is where AI comes in. You know, what makes AI so interesting to me is that it's more analog in how it works. It's flexibly dealing with nuance and context. It can not only handle the structured data, but it can handle unstructured data. And the coolest thing is it can even handle misstructured data, where somebody made a mistake. Flexibly dealing with all of that. And so with AI, we can take John Doe and know that it's John plus Doe, or even J period Doe at XYZ Architects, that it's the same person. AI can fill in the gaps. And so we have this opportunity now to use AI in a new way and embrace fragmentation. So think about how we've been moving our data to the cloud for years. We've been moving our services, repackaging tools into cloud services where we can compute on them. And now we have AI. AI that can use context and reasoning to turn information into intelligence. And so this is kind of the term that we're using of this new reimagining of BIM. We call it building intelligence modeling. It's not just, you know, reporting the same old idea, it's how do we reimagine and go to the next 20 years of a new paradigm. And it's built on these three main concepts: contextual intelligence, inclusive intelligence, and active intelligence. So at my company, we're on a journey to kind of reinvent and reimagine BIM using these ideas. And we're building a next generation tool to do CAD and design and connect to the fragmentation and so on. I don't have that today. We just released our first product 3 months ago, and that's a collaboration tool. So I'm going to show you some of that as a demonstration of these three concepts. But I want you to understand this is a journey that we're going on into the future. And that one day you can imagine how this will grow up. So I'll show the now using contextual, inclusive, and active intelligence, and then we'll talk about how we can develop. So, step one, contextual intelligence. Where are we now? Well, if you think of any real-world building project, there's a lot of CAD data out there. And CAD companies love to think about CAD. CAD companies focus on modeling so that we can get to that documentation. But you as an AEC professional, you don't just have a CAD problem, you have a project problem. And that is everything from mood boards, costing estimates, you've got code standards that you have to meet. There's all of this other documentation out there. So, in the Motif product, as an example of contextual intelligence, we have this concept of a project in a cloud app where you have boards, and you can open these boards, which are these infinite canvases. And onto that infinite canvas, you can take a bunch of static content and bring it into the cloud. You can organize it and arrange it and put your comments and things like that on it. And that's great. Nice. You can imagine how your non-CAD content can be brought to the team and aggregated and provided as context. The next step is that we have plugins for the major CAD applications. So here we have Revit, and we can publish right out of Revit into the cloud. We can publish all the construction documentation, all of the 2D sheets. It's all there in the cloud where it can be used in a review session and organized. So we have CAD data and we have non-CAD data, and we bring that context together. The next step is that we also work with 3D data. Here we're publishing data out of Revit into the cloud, but it's not a publish, it's live streamed. So if I make a change in Revit, you're seeing in real time that it's changing in the cloud as well. So we're live streaming 3D data, aggregating it and contextualizing it with our 2D and non-CAD data, mood boards and sheets and all that stuff, and it's live. But we can take it the next step further, because people don't just use one tool, they use multiple tools. What if I want to add to this building an art piece that comes out of Rhino? Okay, a different CAD tool. So here we have a user in Rhino. They're not publishing, it's live streaming. We're aggregating the data from 2 different CAD tools simultaneously. You can see that now we've gone back into Revit and we've got to add a support beam there. So we're putting in that beam, and you see the beam show up in the cloud. Now somebody has to make the support struts for the art piece. Those support struts are showing up in real time in the cloud. So, contextual intelligence, bringing context that's distributed across multiple companies, it's distributed in multiple tools. It's a way to reduce that fragmentation. And we don't need to own the data. That data can remain officially the sources of truth in those different companies. The next step here is that we can comment on the data. As I said, this first product is a collaboration tool, and so we want to have discussions. So here are threaded discussions, and I put a comment, but I'm not commenting on a 2D image of the model. Those comments are associative with the actual objects in 3D, and they're bi-directional. I made a comment in the cloud collaboration tool, and it showed up in Revit. If I put a comment on the art piece, it shows up in Rhino. Everything knows where the data came from. When you comment on it, it's bi-directional communication. So you've got your engineers now working with your customer who's non-technical. Everybody can bring this together. And that's what I call inclusive intelligence, when it isn't just the professionals that get to participate. It's the people paying the money to get the hospital, to get the school, to get the airport. They now can all be involved in the discussion and connect that data backwards. But it's more than just comments and threaded discussions. We can do sketching. It's the most natural thing that everyone understands. So drawing, not on a 2D picture of the model, but sketching in 3D, in context, multiple users. It's like a Google Doc. It's live. It's not like a dead document like a PDF. It is live where everyone can see the 2D content, the 3D content, the markups, the comments, and it's all bi-directional. Those comments even work when you're doing it on the sheets. So if you make a comment on a 2D sheet, that's associative back into your Revit where you can see it there. All right, the other way that we make this inclusive is in the user interface. It is designed, again, to be used by professionals, but also non-professionals. And I've shown you a bunch of these things, but the thing I want you to see on the right there is history. Everything that's happening in this system is being tracked. Microtransactions, every strut moved, every I-beam replaced, every comment, every little thing is being tracked in microtransactions in a database in the history, even though we don't have the single source of truth. It's distributed data. And that allows people to go back and figure out how was a decision made? Why was that decision made back then? You can also branch off and say, well, maybe I want to explore a new direction and go off in a different direction with this design idea. Now, the third type of intelligence is active intelligence. And this is where we're going to leverage AI as a participant in the project. You're all here because of the impact that AI is going to make. And so if we're going to rethink BIM, we have to really rethink BIM as a participant in this system, in this distributed data system. And so I want you to keep this quote in mind. This has been very important to me. We want AI to do our dishes so that we can do art. What we don't want is for AI to do our art so that we can end up doing the dishes. And I think this is where a couple companies have gone a little bit astray by not keeping this in mind. And so I've spent a lot of time with the team trying to think about what are those things that really energize AEC professionals? What are the things you want to do and add value with? And what are the things that are drudgery, where we really want to apply AI because they're draining? And so, based on that thinking, we've kind of made ourselves a map. I'm lucky enough to have hired, a team of research scientists, machine learning and artificial intelligence scientists, who are doing some really groundbreaking research. There's a lot of stuff out there for using AI with language data. There's a lot out there for working with image data, working with videos. You even have AI working with speech, okay? But there's very, very few AI solutions that go deeply into understanding how buildings work. And that's why we have this research team inventing new models, combining other models, and trying to push the envelope for this industry. And we're actually starting to see, as people start to adopt these tools, we're starting to see people are changing the workflows. It isn't just about speeding up the workflow that you already have. In some cases, maybe we don't want to do the old workflow. I have this one architect here says that design workflows are going to reverse, where we don't go from modeling in a CAD tool and then rendering it to show to the client. Maybe we should start working with our ideas with the client, having AI render them directly, and then think about everything else. And so in step 3, I'll give you an early demonstration of this active intelligence, where, again, in our collaboration tool, I've showed you that we can do sketching, we can do 3D sketching, 2D sketching. Here, done some sketches. And we can take our AI tool and amplify them. Now, you've seen tools that can do AI kind of rendering, but we, through our research, have taught the system much more about how buildings work so that you get better results for the AEC industry, being able to take these sketches and play what if with them. Or you could take products from a product catalog and maybe put them more into context, or maybe some building blocks that you have an idea for a different design, and you can amplify your ideas now in a variety of ways. Not only can you take these 2D sketches or pictures, but you can actually work with your 3D BIM model. So here we have a Revit model, and we're going to take some views of that Revit model, and we're going to use the AI to render these in a variety of ways. Now, notice how simple the AI is there. You tell it what time of day you want. If you're outside, you tell it what kind of weather you want. You tell it the style of rendering that you're looking for. Sometimes you want photorealistic, but many times architects want a watercolor diagram because they don't want the client focusing on the carpet color. They want them to really comment on the overall shape of the space. And so watercolor is a good way to do that. So here we're working with AI, sometimes giving it a prompt, sometimes not giving it a prompt. You can actually start with an output image that you like and then make that the beginning of your next iteration and say, take this image I like and take it to the next step. Organize it, arrange it, throw away some, and again, turn it into some kind of presentation. Now, in this next example, I'm using the sketching tool to sketch something that I know exists. I'm looking for a detail out of my detail library of some kind of truss. So I can sketch this out with the sketching tool. And here, you can see our research is that we're using machine learning to find out of 40 years of data that's been in a variety of projects, find me things like this. So I can do a sketch and say, I want things more like this and less like that. And it can go through hundreds of thousands of details or drawings or whatever and find you that content again. I've heard that some customers spend, one manager from Clayco was telling me that he spends 20% of his day just looking for stuff because the alternative is having to recreate it. Okay, so we have a collaboration app that embraces fragmentation. Where do we as an industry go from here? What's next? Well, our ambition is to reinvent BIM. I've mentioned that, both in what it does and how it does it. And so I've given you the examples of the three whats, the contextual, the inclusive, and the active intelligence. But now let's talk a little bit about the how. And I might nerd out a little bit here. I'll try not to. But if we're going to embrace the fragmentation of data and connect to it, we need new ways of managing all of that data. The I in BIM, information, was always the real promise. And I think out of BIM, it's that I that really we haven't had delivery on. That promise has always been there. It's still there. That's really what we're talking about, is taking that data, that information in BIM, and not just making it about 3D to documentation. This has been the most frustrating part, is that data model. So let's dive in to data. Now, if you think of traditional CAD, most common CAD products on the market today use these principles. If you were a computer scientist, you would have studied design by inheritance, or object-oriented programming, or class libraries. If you're not a software engineer, just trust me on this, this is the term they use. And the way these systems work in their heart, in the bones of these CAD systems, is they organize objects and data into these hierarchies, like a family tree. And just like in a family, you inherit traits from your parents. So I can have this mechanical object. That mechanical object happens to be a compressor mechanical object, and that compressor mechanical object happens to be a 900-watt compressor mechanical object, and so on. And so each level of the tree has properties. Properties are data. And as you go down the tree, you specialize and add more data of that type. So this has been transformational. This comes from 35 years ago, object-oriented programming, and it's been really great. But what do you do with a heat pump water heater? It doesn't fit. It's kind of all three, and it's kind of none of the three. And you need to describe its properties, its data. And this is kind of another form of fragmentation, a data fragmentation. You can't have three parents in a family. Yikes. Now, there's another industry. We've talked about manufacturing as being the inspiration for BIM, but there is another industry out there that makes things. They make one of something, like we do. They do it with an ephemeral team that blows apart when the project's done, and they do it over short time spans, like we do. That industry is the entertainment industry that makes our movies and our games. And what's really interesting is if you study this other industry and how it's working from a computer science background, they use a new technique called, well, it's not really new, but it's new to be applied, called design by composition. And one embodiment of that is what Sean showed yesterday in his keynote, USD, Universal Scene Description, is a form of design by composition. There's another one that's used in the game industry called ECS, or the Entity Component System. So let's see how that works. The ECS is a much more flexible way of dealing with data. Okay? Rather than inheriting properties in a tree structure, an object like our heat pump water heater can point to and refer to different packages of data that are like Lego bricks that you snap together. I can have a Lego brick that talks about the mechanical properties of an object and another Lego brick that talks about the electrical properties of the project. They're both correct. And each of those sets of properties can be managed by a different tool. So it is a lot like how Lego bricks can make a variety of different objects from simple parts. And there's kind of three benefits that you get when you work this way. The first benefit is that it, of course, becomes much easier to compose and manage all of this data because it's so much more flexible and not brittle. It's also dynamic rather than static. If I want to add cost information to a model, I can just bring that in without breaking the other tools because the other tools are only pointing at their own data. They don't care that additional data is being aggregated. And the third thing is that you get a huge speed increase because using this design, you can use parallel processing. Traditional CAD systems like Revit do things in serial. It doesn't matter that you have a 24-core CPU Intel processor. Most of the Revit code runs in serial. Okay? But when you use a different data structure, you can parallelize that. And if we move that to the cloud, we can make it even that much faster. So regarding performance, I had one of the customers I was talking to says that he has his designers wake up from home, they remote desktop into their computer at work. They get into a car, drive through Los Angeles traffic, get to work, and their file's still not opened. That's what traditional CAD products are like today. But by shifting to these new data models that are open, they're extendable, they're linked, they're not centralized, they're flexible. It shifts some of the power away from the vendors and gives it back to you, the customers, the AEC professionals. It allows you to mix and match your solution much more easily. And with ECS in the cloud, you can scale up and you can scale out for performance. You know, you can connect to all these different services while keeping everything tracked. And as you can tell, I spend a lot of time thinking about data. It's the foundation that AI agents work with. And so we have to think about data if we're going to have AI get rid of our drudgery. AI, as you've seen a lot of metrics at the various presentations, it's growing like crazy, as you know. It's the exponential growth is at a rate that's 5 times that of Moore's Law. And Moore's Law is what kind of gave us the entire computing industry. It's 5 times that rate. It's huge. I did some projections and some calculations on what some of the future data centers are going to look like to run these AI models. And it's predicted it's going to take 9 gigawatts for a modern AI cloud data center. And that's about the same amount of power as India consumes. So we're talking about country scale models. So we're doing a lot of machine learning research and AI research in our company. Why is that? And that's because the big foundational models where all that money has been spent, well, those big foundational models were trained on the data of the internet. And what does the internet have to say? Well, the internet has a lot to say about pumpkin spice lattes. It has a lot to say about what color that dress is, and it has an awful lot to say about hairless cats. And yes, that is my crazy cat. What these systems don't do is they don't have a lot to say about HVAC systems in a multi-use high-rise building. And that's the challenge. Because buildings aren't language, they're not speech, they're not images. They're really a graph of vector-based data and schemas and a lot of complicated stuff. So, of course, those of you who've been in the AEC industry for a long time, you have a lot of data. And traditionally, we've had this relationship where the software vendors take your money and they give you the software, and you have the data. Now with AI, they badly want that data, right? And I think there's this short window of opportunity where you can reverse the flow. You've got the data, you can take some of the money. You have something of value that they want and need. The vendors are the ones that have the computer scientists. They're the ones that have the research scientists that know ML. You can do ML activities in your companies. You can hire some programmers. You probably did. You can experiment, but you're probably not doing some of the foundational research. That's really what the VC industry is set up to help fund those very expensive activities. So I think this system is in stalemate. And when I talk to AEC firms, there's three main fears that I hear about sharing data. The first is you don't want your trade secrets that you've worked so hard to build going into an AI model that is then going to leak that trade secret out to all of your competitors and take away your advantage. The second thing that you're scared of is that you want to be compensated for the value. You know that data has value. You just don't know how much value. Is it worth $1 or $1 billion? Nobody knows. You don't have a business model for that. So you don't want to sell the house for $1. And number three, you may not own the data because you've got these weird fuzzy relationships with the client owning some, and you've got a structural engineer, and you've got somebody, it's like, who owns the data? It's sometimes a fuzzy relationship. So because of these fears, you know, the AEC industry is simply not sharing their data, and they're trying to do things in-house. And I think it's great that you have in-house activities. It's a way to differentiate yourself from your competitors. But realistically, if you look at all of the companies 20 years ago that were trying to do CAD in-house, it's very hard as a professional trying to do AEC to also compete with software vendors that are purpose-built and serving multiple companies. So yes, you should do AI in your company, but you should also realize that there's going to be a lot more investment outside of your company. So this stalemate is bad for both sides. And what I want to leave you with are a couple thoughts, is that as soon as one big AEC firm shares their data with these vendors, the value of all of everyone else's data just goes downhill. Put another way, as soon as AI learns about how to make a pumpkin spice latte, every other YouTube video on making pumpkin spice lattes is less valuable. So, how do we break out of this stalemate? And I'm proposing a new way. Break it into two parts. Part one, and that is have a research license where you license your data to a software vendor in a way that's for non-commercial use, where that model has to be deleted at the end of the research. It cannot be used externally in the external world, just for research. And then you, after you've done that, now you've seen what the value of that data is, then in phase two, you worry about licensing the data, and if you want to license the data. But let's get at least through phase one and find out what this data is worth by trying to invent these new algorithms that can serve our industry. All right, so I'd like you to hear another point of view from another industry. You've got the financial industry and the consultancy industry, and here is one of the leaders from OpenAI talking about this very problem and why you may not want to sit still in the stalemate.
Yeah, so the starting point for this is a few years ago, there was a lot of interest in training industry vertical specific models. That finance companies would say, we've got all of this data that no one else has, and we're going to train a finance model on top of GPTs or on top of Llama, and it's going to be so much better. And actually, all of those were worse than the next generation of GPT, because the power of intelligence and the ability to synthesize new information was bigger than the power of sort of memorizing the old information that you have. So that's I think, what this theme looked like a couple of years ago. But fast forward a year or 2 years. Now the story is I have all of this proprietary data, I've accumulated it over years, and in some sense, for a lot of times, if that data is teaching the model a skill, or if it's meant to teach the model a skill, that data is sort of embodied labor, right? Someone worked through all these case studies. Someone called all of these customers and found out all of this information. Well, that embodied labor is now free. AI can do all those things. And so now there's an opportunity. You can have AI call all those customers, do a big survey, find out what they know. You can have AI work through all the case studies.
And so, I want you to think about that and think about the fact that software tools are not strategic to your business, because if you at firm A buy one of these products and firm B has the product, you get the same functionality. By definition, if it's the same, it's not strategic. doesn't differentiate you. And I think now with AI, you've got to start thinking about, yes, you should be doing some inside your own firm because everyone can be a coder now. This program was vibe coded by a product manager at my company, not an engineer. So simply by talking to an AI, the AI wrote the program, and now the product manager is using that to help our engineering team understand what to build. So any new technology follows this adoption curve, whether it was the internet or AI, and that is that it starts out being impractical and people don't use it, and then people adopt it more and more as it becomes more practical, and generally you get the big shift when everyone else is doing it. So everyone is going to use AI when everyone else uses it. Remember with the internet, people said, oh, I can't put my company data on the internet because of security and this and that, and then when everyone else started putting their data up there in Dropbox and what have you, then you started doing it. The problem with this adoption curve is that it's not the value curve. The strategic value of something is figuring out when it has some value and that it's actually possible to use the tool, but before other people adopt it. And that means you have a small window to get ahead. So yes, there's safety concerns with AI. There's liability concerns with AI. There's risk from every angle with AI, but inaction is risky as well. So in summary, we've talked about embracing fragmentation of people, data, and tools. We've talked about inclusive and active. We've talked about how data is the new oil, but it won't be for long. So get out there and do something with your data while it still has value. Everyone is a coder with these tools, so even people who are less technical can use these tools, so you need to train them. And that inaction is a risk. Action is a risk, but inaction is a risk as well. So be early, but not too early. So in summary, from everyone at Motif, I want to thank you for the opportunity to share some of these ideas, and I really look forward to working with all of you in the future, and hope you have a great conference moving forward. And I'll just end with a little quip from Carl, my friend, who used to say that robot is what you call something before it becomes useful. Afterwards, you call it a dishwasher or a vacuum cleaner. And I think this AI conference in the future, if we're lucky, if we do it right, AI is what you call something before it's useful, but once it becomes useful, we'll call it a collaboration or a design tool. Thank you.